Hello everyone, my name is Johanna Princess Saavedra and I am here to discuss to you two problems of drying liquid extraction. So the first problem is a solid B contains a soluble component A of mass fraction XA equals to 0.3 and XB is equal to 0.7 and is to be treated to recover A by solvent extract with C. Solid B and solvent A are mutually totally insoluble. The extracted solid is to be screw pressed to a pound of solution per pound of B in the underflow. The entertainment of B in the overflow A can be neglected. A. Calculate the pounds of solvent C, which is the A free that must be fed per pound of fed solid to obtain 90% of the A in the extract overflow. B. Calculate percent A in the overflow solution. So we have the first problem is we have a solid B containing a soluble component A with is equal to 0.3 and XB is equal to 0.7. We want to recover 90% of A using solvent C. So B and C are completely insoluble and the underflow has 1 pound solution per pound of B. We need to find A pounds of solvent. We need to find the pounds of solvent, which is S. And for part 2 is we have to find the percentage of A in the overflow solution. So our is to write down our basis. So our mass of A is equal to 0.3 pounds and our mass of B is 0.7 pounds. So since our recovery is 90%, so A recovered is equal to 0.9 and multiplying to the mass of A, which is 0.27 pounds. So next step is we have to underflow. We have to find the A left in the underflow, which is subtracting 0.3 to our 0.20. So we have 0.03. So next is explaining our underflow. Underflow has only 1 pound solution per pound B. So in total, solution in the underflow is multiplying 1 pound to our 0.7 pounds. So this is equal to 0.7 pounds. Next is the concentration of A in the underflow. We have to divide 0.03, which is the A left in the underflow, pounds over our total solution, which is the 0.7 pounds. So dividing 0.03 over 0.7, we have 0.0428571426 pounds A over pounds solution. Next is at equilibrium, concentration in overflow equals concentration in underflow. So let S be the mass of solvent C. So when our overflow has 0.27, which is this one, and our looking for S is 0.27 over 0 plus S is equal to our concentration of A, which is 0.0428571426 pounds A over pound solution. So using shift solve, our overflow our S is equal to 6.03 pounds. So we need 0.03 pounds of solvent C per pound of feed. So next is getting our percentage A in the overflow solution. So only thing now for the percentage of A in overflow. So first is our getting our total mass of overflow, which is adding 0.27 pounds plus our mass of solvent, which is the 6.03 pounds. So adding this, we have the total of 6.33 pounds. So in getting our percentage A, we only have to divide 0.27 pounds over our 6.30 pounds, which is multiplying 100%, we have a 0.27 over 6.30 times 100 is equal to 4.285714286 percentage. So in total, we have a 4.29 percentage of A in the overflow solution. So that is the answer of our problem number 1. So we have the next problem. So the second problem is how many stages and how much water is needed for the counter current extraction of NaOH from a feed consisting of 80 pounds NaOH, 400 pounds water, and 100 pounds CaCO3. The final extract solution will contain 10% with a recovery of 95% of the NaOH we shall set the underflow at a constant 3-pound solution per pound CaCO3. So the second problem is a countercurrent extraction of NaOH. So we have the feed, which is the 80 pounds NaOH and containing 400 pounds water and 100 pounds CaCO3. So we want 95% recovery, and the final extract of NaOH is 10%, and underflow is at constant at 3 pounds solution per pound CaCO3. Calcium carbonate. So we have to find the amount of water needed and number of stages required. So our is balancing our NaOH. So material balance for NaOH, we have a NaOH recovered, which is a 95%. So 0.95. We have to multiply this to our 80 pounds NaOH. So in total, we have 0.95 times 80 is equal to 76 pounds. So our next, we are getting our NaOH remaining, which is to subtract our 80 pounds NaOH and our 76 pounds NaOH recovered. So in total, we have 4 pounds. And the next step is the extract calculation, which is we have our final extract, which is the 10%. So 10, 0.10 is and 76 is looking for x. So we have to multiply. We get 760 pounds. So our water in extract is subtracting our x to our NaOH remaining. I mean our NaOH recovered, which is the 76 pounds. So 760 pounds minus 76 pounds is equal to 684 pounds. So next is our, wait, I'm just gonna put it here, our extraction calculation. And look, next looking for our underflow calculation. So our underflow solution, which is the 3 pounds, we have to multiply this to our 100, which is the pounds of calcium carbonate. So multiplying 100 to 100 pounds is equal to 300 pounds. And the water underflow is subtracting 300 pounds to our 4 NaOH remaining. So we have 96 pounds of our H2O in underflow. So the next step is we have to get the water required. So in getting this, we just have to get the total water out. We have to use the formula water in extra plus water in underflow. So water in extract is the 684 pounds plus our water in the underflow, which is 296 pounds, is equal to 980 pounds. So water already in the feed has 400 pounds, which is, yes, and the water added is, we have to multiply, like we have to subtract our water, water out, and our 400, which is in the feed. So this is equal to 580 pounds. So the next step is we are looking for the number of stages. So for the number of stages, we can do a stepwise calculation, which is assuming equilibrium y is equal to x. So our starting concentration, which is x, 80 over 480 pounds. So 80 over 480 is equal to 0.1667. So our stage 1 consists of y is equal to 0.10 and our x1 is equal to 0.102, and our stage 2 is containing 0.0, and our x2 is also 0.04, because yeah, we have been assuming equilibrium. So I'm just gonna put it here, y is equal to x. Next stage is our y3 is equal to 0.016, and our x3 is equal to 0.16, and our stage 4 is equal to 0.0064, which is below our target, which is our xn is equal to 0.0133. So approximately we have in total of 4 stages. So, and that's it. We found problem A, which is the 6.0 pound solvent needed for our 4.29% A in overflow. And in our problem 2 is we got our 580 pounds water required and about 4 stages. I hope this helped you understand how to solve leaching problems. So thanks for watching and see you in the next video.